Okay, this is the foldable for section 4.1 and 4.6. We're going to start from here and fold it inward towards the line. And what we're doing here is we're classifying triangles by angles. And then on this side, we're classifying by sides. So this one's by angles. What I want you to know is that when you add all the angles together, they're always going to equal 180. So when you add all the angles of a triangle, they're going to equal 180. Acute, to remind you, is when all angles are less than 90 degrees. Obtuse is when one angle is greater than 90 degrees. And then a right triangle is when one angle is 90 degrees. And we usually note the symbol like this, and that should tell us that that equals 90 degrees. On this side, we have classification by sides. Scaling means that no sides are equal. Isosceles, the definition says that at least two sides are equal. But we're just going to go with two sides are equal. Because when all three sides are equal, we're going to call it an equilateral. All sides are equal. One thing that I want you to know is that if something is an equilateral triangle, then it is also equiangular. Sorry, Noel. Ugh, I'm not sure why I'm spelling this really wrong. Equiangular. It has a U somewhere. Okay. Equiangular. What equiangular means that all angles are equal. The lateral, telling us that all sides are equal, also tells us all angles are equal. The other thing that I want you to know is that if we know that a triangle is equal to 180 degrees, and all the angles are the same, that means we can divide by 3 and say that each angle is 60 degrees. So if we know it's equilateral, we know that it's equiangular, making all the sides equal, all the angles equal. Okay, so how would we apply it to our class? We have an acute angle right here. That means that all of them are equal or less than 90. We're going to add them together. 65 plus x plus 15 plus x, because of this one, is equal to 180. We're going to combine like terms. 65 plus 15 is 80. X plus x is 2x, and that's still equal to 180. Minus 80 to both sides. 2x is equal to 100. Then divide by 2. X is equal to 50. So that's your value of x, and on your test I tend to ask you to find the value of x, but then use it, so we will use it here. If I know that x is 50, 50 plus 15 is equal to 65. That means that this angle right here is also 50 because that's the value of x. Because these two base angles are equal, we actually do know that this will be an isosceles triangle, that the two sides are equal. Just like we knew when the sides were the same that the angles are equal, we know the converse, that if the angles are equal, then the sides opposite will be equal. This is an obtuse, but it will work the same way. We have 25 plus x plus 20 is equal to 180. We're going to add these two together, giving me 45 plus x, still equal to 180, minus 45 to both sides. X is equal to 135. That means that this angle measure is 135 degrees. A right triangle, we still know that when we add them all together, they equal 180. So we have x plus 90, and we can tell by that symbol right there that that's 90, plus x plus 20 is equal to 180. Combine like terms, that would be x plus x is 2x. 90 plus 20 is 110. That's equal to 180. Subtract 110 from both sides. 2x is equal to 70. Divide by 2. X is equal to 35. Sometimes I will ask you what's the angle measure. That means that this one right here would be 35 degrees. 35 plus 20 is 55. That means that this angle right here would be 55 degrees. On the other side, we can tell that this is scaling because none of the sides would be equal to one another, but we'd still add them together to get the perimeter. It says the perimeter is equal to 30. That means that we have 6x plus x plus 8x is equal to 30 this time because of the perimeter. Six plus 1 plus 8 gives me 15x is equal to 30. So then we're going to divide by 15 to both sides. X is equal to 2. To figure out the side lengths, we're going to do 6 times 2, which gives you 12. This is just equal to 2. And 8 times 2 is 16. Verifying that none of the sides are equal, making it a scaling triangle. Isosceles. When you have two sides that are equal, you set the values equal to each other. That means x plus 15 is equal to 4x minus 5. I'm going to draw a line. I'm going to subtract this x. That means I have to add this 5. Have 20 is equal to 3x. Then divide by 3. It's 0.6 repeating is the value of x. We could plug it in to verify that it's an isosceles, but this notation is enough. If I ask you on a test to give me the side length, make sure you plug it back in. For an equilateral triangle, sometimes they give us too much information. We know that we can set the two sides equal to each other, and you can set any two sides equal to each other. So kind of the third side is too much information. We're going to subtract 2x from both sides. I'm going to add 6 to both sides as well. Have 2x is equal to 10. Then I'm going to divide by 2. x is equal to 5. Just to verify that you got the correct answer or that it's actually an equilateral, you can plug it in. So 4 times 5 is 20 minus 6 is 14. 2 times 5 is 10 plus 4 is 14. 4 plus 9, 5 plus 9, sorry about that, is also 14, and we know that it's an equilateral triangle. Remember what I've mentioned before is that if you have that all sides are equal, so are all the angles. The other thing that I want to mention is that if I ask you, what is this length, and I give you coordinates, for example, 3, -2, 3, -4, I'm looking for the distance between them, so you have to use the distance formula.